Hey, what's going on, guys? Let's solve these problems right here. The first question is asking a 1.3 meter long gas column that is open at one end and closed at the other end has a fundamental resonant frequency 80 Hz. What is the speed of the sound in this gas, right? To find the speed, we have to use this equation, V is equal to F lambda, right? Here we don't have the lambda, we have the frequency but we don't have the lambda, and this they are saying this is open at one end and closed at the other end, and this is fundamental resonance frequency. So fundamental resonance frequency means this is going to be the wave, right? So this is going to be the wave, and if you look at this is lambda by 4, right? Lambda by 4, and they have given the length of this gas column, that is 1.3. Lambda by 4 is equal to 1.3. Therefore lambda is going to be 1.3 times 4. So this is going to be our lambda. Now all we have to do is just simply plug in this equation. This is going to be 80 times lambda, that is 1.3 times 4. And if you calculate this value, you should get 416 meter per second. So the answer is going to be 1, right? Okay. Let's look at the second question. A 0.25 meter string vibrating in its sixth harmonic excites a 0.96 meter pipe that is open at both ends into its second overtone resonance, second harmonic above the fundamental. So second harmonic above the fundamental, it means third harmonic, right? Fundamental and two more. So this is third harmonic. Let's write this one right. Third harmonic, and the speed of the sound is 345 meter per second. The common resonant frequency of the string and the pipe is close to what? So here they are asking for the frequency. Now for a pipe that is open at both end, right? This is saying this is open at both end. We use this equation to calculate this frequency, that is F is equal to NV over 2L. Now N is going to be which harmonic motion this is? This is third harmonic, so we are going to use 3 for N value. N is going to be 3, and we know the length, that is 0.96. So all we have to do is simply plug the values. Here we have the third harmonic, that is 3, and the velocity is provided 345 divided by 2 times the length, that is 0.96. And if you calculate this one, you should get 540 Hertz. Right, so the answer is going to be first one. Now let's look at the next question. The pipe is 0.9 meter long and is open at one end but closed at the other end. If it resonates with a tone whose wavelength is 0.72 meter, what is the wavelength of the next higher overtone in this pipe? So in this kind of problems, the easier way is, if you don't want to make any mistake, the easier way is draw the diagram, right? So here this is closed at one end, open at other end. Let's look at the first harmonic. First harmonic, so we are going to always have a node at the closed end, anti-node at the open end. So first anti-node is this one. That's going to be the first harmonic. That is, if you look at the length, that is lambda by 4, right? Because this is 1/4 of the wavelength. So lambda by 4 is equal to 0.9. So lambda is going to be what? 0.9 times 4. That's going to give us 3.6. So this is not first harmonic, because if it's first harmonic, this should match this value. So this is not first harmonic. The given information is not first harmonic. Now let's look at the second harmonic. Second harmonic, we have to look when are we going to have the second antinode. And first antinode is this, and second is going to be this, right? Second antinode at the end. And if you look at this one, this is lambda by 2 plus lambda by 4. Lambda by 2 plus lambda by 4, that's going to give you 3 lambda by 4, right? So this is 3 lambda by 4. If you solve for this one, 3 lambda by 4 is equal to 0.9. and if you solve for this one you will get 1.2. So this is also not second harmonic motion. Now to check whether it is third harmonic motion, we have to draw one more diagram. Usually, they don't give you too much, like it's maximum fourth harmonic, something like that. So it's not bad to draw the diagrams. So here let's look at the next one, the third antinote. So here we have one full wavelength, that is lambda plus lambda by 4. If you add them together you will get 5 lambda by 4, right? That is equal to 0.9, and if you solve for this one you will get lambda is equal to 0.72. So this is third harmonic, right? And you can already see the pattern. For closed a pipe that is closed at one end and open at other end, this goes like lambda by 4, 3 lambda by 4, 5 lambda by 4, then 7 lambda by 4, 9 lambda by 4, right? So the pattern is going to go like that. Now here's the question is asking, what is the wavelength of the next higher overtone in this pipe? So next higher overtone means they are asking for the fourth harmonic motion. So this is third. Fourth is, according to the pattern, we know that this goes like 1, 3, 5. The next one is going to be 7. So 7 lambda by 4 is equal to 0.9. And if you solve for lambda, you will get 0.51 and some values. So the answer is going to be E, right? And that's how we do this kind of problems. Now let's look at the next question. The sound from a single source can reach point O by two different paths. One path is 20 meter long and the second path is 21 meter long. The sound destructively interferes at point O. What is the minimum frequency of the source if the speed of the sound is 340 meter per second? Now the difference in path, if you look at the difference in path, this is 21 meter long, this is 20. So the difference is 1 meter. Let's get rid of these things. Right, so here we have difference that is 1 meter, because 21 minus 20, that's going to give us 1 meter. So minimum path difference needed for a complete destructive interference is going to be lambda by 2, right? That's equal to 1. And if you solve for lambda, that's going to be 2 meter. So you can find this lambda using this always, right? Now lambda is 2 meter. Here the question is asking for frequency. We have the speed that is provided. V is equal to f lambda. F is equal to V over lambda. V is 340 divided by 2, that's going to give you 170. So this is the C is the answer, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.